is about the second derivative test. So speaking of second derivative test, let's go over the first derivative and the second derivative, and then I will combine both to explain the second derivative test. All right, so first derivative. So when you hear the word first derivative, f prime of x, what is the first thing that you think about immediately? The first thing that you think about immediately is the slope, right? Using the first derivative, we are trying to find the slope of a function. What else? Using the slope, we can find the local maximum or the local minimum, right? So when I hear the word first derivative, first thing that I am thinking is the slope, and then think about the application. I can use the slope to find the maximum and the minimum. How do you find first derivative? First, you need to have a function, right? So let's say f of x equals to a function, and then you find f prime of x, you take the first derivative, and then whatever that equals to, you set that equals to 0, and then you solve for x, right? So the x you have is equals to, let's say, C1 and C2. What are C1 and C2? They are critical numbers. C1 and C2. And then how do you use the critical numbers to determine the min and max? So critical number means something is interesting at that value. So that value is either a minimum or a maximum. So what you do next is you draw a number line, right? And then the number line, you drop the C1 and then C2 down to the number line. So since you have two critical numbers that divide the line into three pieces, so number 1, number 2, and then number 3, you have 3 test interval. And then within each test interval, you pick an x value, right? So x, you pick an x value within each interval, and then you test that value. So you plug in the x value to the f prime. So let's say that is x something. So you plug in this to the f prime of x to determine the slope. So if f prime at that test value, so the x dot 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 is a test value, at that test value, so let's say you have a negative, so that means the entire interval is decreasing, the slope is decreasing. What if you have a positive? So that means the entire interval is increasing. And then how do you use the increasing, decreasing to determine the min and max? If you have a decreasing, and then a horizontal tangent, and then increasing, so that gives you a minimum at C1. If you have decreasing, this one should be the other way around, so this should be an increase, and then horizontal tangent, and then decrease. At that point, you have a maximum, so let's say that is a C2. So that's how we used the first derivative. So we take the first derivative, set that equals to 0, find the critical numbers, drop the numbers on the number line, then determine the test interval, and then you pick a value within each test interval to plug it in to the f prime to see if the interval is increasing or decreasing, right? What about second derivative? So second derivative, what do we do? So second derivative, what is the second derivative for? So every time I say second derivative, what is the first thing that you think of? So you have to make it to this video. So when I say the word second derivative, you are thinking about concavity. So if you don't know what concavity is, you have to watch the previous video. All right. So concavity is either concave down or concave up. So concave down is a parabola that is facing down. A concave up is a parabola. It's like a bowl that is facing up. Another way to picture concave down and concave up is concave down is a sad face, and then concave up is a happy face. All right. How do you determine concavity? First, you need to have a f of x, and then you take the first derivative, right? And then you take the derivative again, you have a second derivative. So this time, whatever the second derivative is, you set that equals to 0, and then you are able to find a couple critical numbers. So let's say x is equals to C1 and C2. So you have two critical numbers. And then what do? Just like the first derivative, you drop these critical numbers on the number line. All right, so you have C1 and then C2. And then you divide the line into 3 intervals, and then you pick a test value. So let's say this is x1 is between negative infinity to C1, x2 is between C1 and C2, x3 is between C1 and positive infinity. And then you plug it in into the second derivative. So you plug it in, f double prime of x1. Again, x1 is a test value inside a test interval. So let's say you have a negative. So f double prime is negative. That means the function is concave down in the interval. What if you have a f double prime of x2 is positive, just a what if, then the entire interval is concave up. So if you go from concave down to concave up, the picture should look like this. So this is concave down, and then at C1, that changes to concave up. So from down to up, the C1 is the point where the concavity changes. So this point is called an inflection point. What if you go from concave down to concave up? So this, what if you go from concave up and then to concave down? And then this point is also an inflection point. Now, the second derivative test, the stuff that you just saw in red, that is not really the second derivative test. The second derivative test is we are trying to combine the first and the second derivative. All right, so let me switch color again. So now I am trying to combine the concept in the first and second derivative to create a second derivative test. So here, I am going to draw an arrow like this. So I am going to create a second derivative test that requires you to understand the first derivative and the second derivative. So this is how we do the second derivative test. So you have a function f of x, right, that equals to something, and then you have to find f prime of x. You take the first derivative, whatever that equals to, you set that equals to 0. And then you solve for x, all right? So that is what you do in first derivative, right? So let's say x equals to c1 and x equals to c2. You have a critical number, right? So they are your critical numbers. What is critical numbers? So critical number means the c1 and c2 is either max or min, right? Or none. So either a max or min. Okay, what about second derivative? We haven't done any second derivative yet. So now you have a couple critical number from the first derivative, and then you go ahead and take the second derivative. All right, whatever that equals to, we don't need to set that equals to 0. So what we are going to do right now is I am going to use C1 and C2 in the second derivative. Now, you might ask me, hey, the C1 and C2, they are from the first derivative. Why do you put them in the second derivative? Let me explain that right now. So we are going to do f double prime of C1 and then f double prime of C2. All right, so just for example, let's say f double prime of C1 is negative, f double prime of C2 is positive. What does that mean? So think about this, second derivative, negative. That means the function is concave down, right? When I say second derivative negative, you are thinking about concave down. So this is concave down. Now, I am saying that second derivative is positive. So what you are thinking? You are thinking about concave up. Okay? So now, what did we say about the critical numbers for the first derivative? It's either a max or a min, right? So now, you have a concave down. Look at the f double prime. Oh, look at the f double prime. You have a concave down, right? The parabola is facing down. Facing down, is this point supposed to be a max or a min? This point is supposed to be a max. Concave up, then this point is supposed to be a min. All right, so that's how convenient the second derivative test is. We don't need any more sign charts. So we find the first derivative, set that equals to 0, get the critical numbers, and then we plug in the critical numbers to the second derivative to see if that is a negative or positive. Second derivative negative, you have a concave down, then the critical number must be a max. Second derivative positive, you have a concave up, then the critical number must be a local min. Now, tell me the exact location of local min and local max. To find the location, you have to plug in the critical numbers, the C1 and C2 to the original function f of x. So you have to find f of C1 and then f of C2. Whatever that equals to, you get a xy coordinate, right? So this one is a local max, and then this one is a local min. So that is how you do the second derivative test. All right, so let's go ahead and then do a simple example. I'm going to do a very simple example right now. So second derivative test. So let's go ahead and then do an example right here. Okay, so let's say we have a function f of x equals to x to the third minus 3x squared plus 3. I want to use the second derivative test to find the local mean and local max, no more sign chart. All right, so f prime of x, that is equals to 3x squared minus 6x. That we have to set that equals to 0. So we are going to get the critical numbers right here. So you have 3x, factor it out, x minus 2 equals to 0. So x equals to 0 and x equals to 2. They are my critical numbers. And then you proceed to the second derivative. So that is equals to 6x minus 6. Again, no more sign chart. So first you plug in the critical number to the second derivative. So that is equals to 6 times 0 minus 6. That is 6 times 2 minus 6. So that is equals to negative 6. That is equals to positive 6. This is negative. This is positive. So second derivative negative. That means the function is concave down at that point. Second derivative positive. That means the function is concave up at that point. So what is concave down look like? Concave down is a set phase. So since a 0 is a critical number, so at x equals to 0, we have a local max. And then 2 is a critical number. At x equals to 2, concave up, we have a local min. Because look at the first derivative, we set that equals to 0, right? So at x equals to 0, we have a horizontal tangent. At x equals to 2, we have a horizontal tangent. So I just found the max and min. Can you tell me the exact location of max and min? Sure. So f of 0, that is equals to 0 to the third minus 3 times 0. We plug it into the original function. That is equals to 3. And then f of 2, that is 2 to the third minus 3 times 2 squared plus 3, that is equals to negative 1. So 0, 3 is my local max. And then 2, negative 1 is my local min. So that is how we do the second derivative test. All right. So if you think my video is helpful to your study, please subscribe, click the like. Trust me, it is worthwhile coming back. I will see you all in the next video.